Welcome back to the module. Let's continue this time with Lecture 3. At its core, science is concerned with developing an increasingly accurate understanding of the world around us using observation and reasoning. Scientists attempt to be as objective as possible in the interpretation of the data and observation they have collected. We discuss this way of doing science later in this module, but it is important to understand that much of science is purely descriptive. To understand anything, the first step is to describe it completely. Efforts are currently underway to classify all life on Earth. Deductive reasoning applies general principles to predict scientific results. On a day when sunlight shone straight down a deep well at Syene in Egypt, Eratosthenes measured the length of the shadow cast by a tall obelisk in the city of Alexandria, about 800 kilometers away. The shadow's length and the obelisk's height formed two sides of a triangle. Eratosthenes calculated the angle A to be 7 degrees and 12 minutes, exactly 1/50th of a circle. If angle A is 1/50th of a circle, then the distance between the obelisk in Alexandria and the well in Syene must be equal to 1/50th circumference of the Earth. Eratosthenes had heard that it was a 50-day camel trip from Alexandria to Syene. Assuming a camel travels about 18.5 kilometers per day, he estimated the distance between obelisk and well at 925 kilometers. Eratosthenes thus deduced the circumference of the Earth to be 50 times 925, or 46,250 kilometers. Modern measurements put the distance from the well to the obelisk at just over 800 kilometers. Using this distance, Eratosthenes' value would have been 40,000 kilometers, that's 50 times 800. The actual circumference is 40,075 kilometers. In inductive reasoning, the logic flows in the opposite direction, from the specific to the general. Inductive reasoning uses specific observations to construct general scientific principles. For example, if cheetahs and snow leopards have hair, and every felid that you observe has hair, then you may conclude that all felids have hair. Inductive reasoning leads to generalizations that can be tested. Figure 4 illustrates how scientific investigations proceed. First, scientists make observations that raise a particular question. They develop several potential explanations or hypotheses to answer the question. Next, they carry out experiments to eliminate one or more of these hypotheses. Then, predictions are made based on the remaining hypotheses, and further experiments are carried out to test these predictions. The process can be iterative. As experimental results are performed, the information can be used to modify the original hypotheses to fit each new observation. The meaning of theory is the body of interconnected concepts supported by scientific reasoning and experimental evidence that explains the facts in some area of study. To a scientist, theories are the solid ground of science, expressing ideas of which we are most certain. In contrast to the public, the word theory usually implies the opposite, a guess. Some critics outside of science attempt to discredit evolution by saying it's just a theory. The hypothesis that evolution has occurred, however, is an accepted scientific fact. It is supported by an overwhelming evidence. Modern evolutionary theory is a complex body of ideas, the importance of which spreads far beyond explaining evolution. Its ramifications permeate all areas of biology, and it provides the conceptual framework that unifies biology as a science. Much of science is descriptive, amassing observations to gain an accurate view. Both deductive reasoning and inductive reasoning are used in science. Scientific hypotheses are suggested explanations for observed phenomena. Hypotheses need to make predictions that can be tested by control experiments. Theories are coherent explanations of observed data, but they may be modified by new information. Thank you once again for joining us. We'll see you again for Lecture 4 when we talk about Darwin's theory of evolution.